Hey, this is question 2C from the NCEA 2 2012 end of year exam. So let's have a look at question 2C. It says Mark solved the equation blah. His working is below. It says, is Mark's answer correct? Fully justify your answer. In pretty much every single one of these I've ever seen, the answer is no, it's not correct. And you need to explain why. So they usually throw in a mistake. They love throwing in mistakes. And by the way, I do this all the time in what I do as well. And sometimes people, I've noticed, write in the comments, they go, you made a mistake. And sometimes I generally do just make a mistake. But a lot of times it really is to say, look, kids, have a look, see if you notice. And I think it's a reasonably important thing to do. Because the whole thing is in maths, we do something, we notice with something's not quite right, we revise it, we change it, we try again, and we keep on changing until we reach a level of perfection if we can. So this one here, we're going to have a look and see what Mark's done, and he's done a reasonable job on looking at this here. This is actually a reasonable way of doing this, and he's got two solutions. You can actually solve it if you factorize these, just get one solution, by the way. But because this is a quadratic, we do need to acknowledge two solutions, and that's the nature of being quadratic. So this bit here, I'm noticing you're going to, so what he's done is he multiplied both sides by x squared plus x minus 6, and that's what he's done. So he's got the first bit here, this bit here is the same, this bit here is now cancelled, and he's got 4 lots of x squared, which is 4x squared, 4 lots of x, which is 4x, and 4 lots of negative 6, which is negative 24. Now he's subtracted 4x, or he subtracted x squared from both sides. He's going to subtract x squared, there it is, and he's ended up with a 3x squared. He's added 5x to both sides, and 5x and 4 is 9x. And then he's gone 6, and he's subtracted 6 from both sides. So he's subtracted 6, he's added 5, and he's subtracted x from both sides, x squared from both sides. So he will end up with 3x squared plus 9x minus 30. So this is all correct. Then what does he do? He goes ahead and he does a bit of factorizing. He says, well, he takes 3 out. By the way, I wouldn't actually bother taking 3 out. I would just divide everything by 3. In other words, I've got 3x squared plus 9x minus 30 is equal to 0. I would divide this by 3, this by 3, this by 3, and this by 3. 3 divided by 3 leaves me with an x squared. 9 divided by 3 leaves me with a 3x. And 3 goes into 30 10 times. So this is going to be a plus, this is going to be a minus, and this is equal to 0. So I end up with stuff in the brackets, but there's no need at all to leave the 3 there, because if you divide everything by 3, 3 goes into 0 times. So we'll end up with this, which is what we're looking for. And then we can factorize this. So we're looking for factors of 10. So factors of 10 are going to be 1 and 10, and 2 and 5. 1 times 10, 2 times 5. There they are, a little sidebar there. Now, notice the dots are times, yes? So this is going to be bracket, 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 bracket equals. We've got an x, we've got an x. Signs are different. Biggest one's going to be positive. Well, 1 and 10 in no possible combination can make a 3, but 2 minus 5 or 5 minus 2 in various combinations will end up with some sort of a 3, either positive or negative. So signs are different. Biggest to positive, 5 is the biggest. We've got a 2 here. So therefore we can say x will be equal to 2 or negative 5. Oops, having said that, I wrote a 3 for some extraordinary reason. 2 and negative 5. Now, by the way, if you're writing this in set builder notation, you'd always write the smallest one first. X is an element of negative 5 comma 2, and you write it like that. But in this case, they've got negative 6 and 2. We've got negative 5 and 2. So they've clearly, the factorization is incorrect. So the other thing we have to do now is, because we've got a fraction here, we have to check and test and see whether the solutions we've got are actually true. So let's put now test for integrity. So we'll do an integrity quick test. Here we go. Let's throw in some values here. So I'm going to throw in, well, I got 2 first, so let's put a 2 in all of this, yeah? So, and I can see a problem actually already. The key thing, by the way, is what's happening on the denominator. Because if I've got here, if the denominator is 2 squared plus 2 minus 6, well, this is going to be 4 plus 2 is 6 minus 6, which is 0. You can't have a denominator of 0. So we have to say here, x equals 0 is not a valid solution, as denominator cannot equal 0. And if you wanted, you could put that into, say, a null solution like that. But the -5 does work. -5 works just fine. -5 squared is 25. And we got -5 is 20. Minus 6 does not equal 0. So that's absolutely fine. So the answer you want to put here is, first of all, you've got incorrect factorization. So the first thing I put is incorrect. Incorrect factorization. That would be incorrect factorization in step 1, 2, 3, 4. The second thing I would note is, oh, I put x equals 0 is not. Of course, x equals 0 is not. X equals 2 is not. What am I doing? Sorry, my bad. X is 2. X equals 2 is not valid. And Mike, or Mark, did not identify this in his solution. So they're the things that I would actually note. Yeah. Right. So I think the best way of saying it's not a valid solution. It's not valid. And you want to actually say why. You want to say because. I would say equation does not equal 4 when x equals 2. So I would just add that bit in there too. Hopefully that would make sense as well.